So our next presentation is by Miriam, Elia, Carola Gajek, Alexander Schiendorfer, and Wolfgang Reif, but I think Miriam is taking over the talking.
Yes, exactly.
And the title will be an interactive web application for decision tree learning. And I saw that you already posted some links, so anyone who's interested in further information can also find links on the Etherpad. Take it away, Miriam.
Of course, thank you. So, first of all, a welcome from me as well. I'm really glad to share the ECML Experience 2020 with all of you. And today, as you've already heard, I will give you an introduction to an interactive web application for decision tree learning. Now, let's start by clarifying the target audience. Originally, the tool has been designed for a workshop at the Girls' Day. And for those of you who don't know what the Girls' Day is, it's basically an event when female pupils get to know considered as more masculine jobs and vice versa, meaning that boys would get to know the job of a kindergartner, for instance. The scenario we thought of was basically giving a short introduction to the theoretical background on decision trees, and then letting the pupils dive straight into the tool and play around with their own trees. But besides working with pupils, there's many more applications possible because decision trees are like the fundamental machine learning model and studied in most introductory level courses, be they at a university or in a company that would like to introduce its employees to machine learning. As you can see here, I tried together a well-rounded overview of possible application contexts. And the aim was basically to create a fun application that the user enjoys playing with while internalizing general machine learning concepts like the split into training and test data set, for instance, and also gaining a thorough understanding of decision trees, entropy, and everything related. Now, let's dive into a live demo of the application. Let me show you what we did. We will start by importing the train data set, which in this case is the tennis data set, and I'm quite sure that most of you already stumbled across it, as it's used in most papers on decision trees. Well, here you can see the decision tree built according to the ID3 algorithm, where each node is split according to the highest information gain. Here is the entropy displayed of the current node, and also its the data instances that it contains. Then under this mode, under automatic mode, the hint section basically tries to give you some facts on decision trees that would be quite useful for the learner to internalize them. Under manual mode, you can build your own decision tree according to whatever idea you might have, maybe splitting according to not the highest information gain, or just hiding the information gain and looking at the data set and then continue splitting. But I've already prepared a whole session for now, because it would simply take too long to build the whole tree right now. And you got the gist, I guess. So as you can see here, we already have a test data set imported as well. And this is our definitely more complex tree now. Everything works just as I've described before. Everything also will work with using the Gini index as a method, not just the entropy. And now we can test the tree on a test data set, which is different from the training data set. And as we can see, it's performing really poorly on this model, because it's just has an accuracy of 43%. If we click on a certain data instance, we see the path that the algorithm took to classify it. Also here, for instance, the model was not able to classify this data instance, because here a new value occurred that wasn't present in the training data set. So basically, this is how we handle like noisy data, for instance. Under manual mode, the hint section tries to be more interactive and gives like maybe hints what the user could do next or how he could try it. That's basically all for now. I will simply show you briefly the default data set. This is in German now, and it was used for the Girls' Day, or we thought of it for the Girls' Day, and it would classify monsters according to speed, color, or strength. So as you can see here, also more result classes are possible, so not just binary trees, and it's possible with up to 10 result classes. And also not just using textual values, but numerical values will work as well. But that's all for now about the live demo. I will go back to the presentation right now, which is here, and I think that I kind of lost my mouse. Okay, there it is. Yes, and F5. Okay, there we were. Now let's talk about further steps. Well, as I already mentioned, the web application was originally designed for the Girls' Day, but unfortunately, it didn't take place this year because due to Corona, and we didn't have an opportunity to really test the application on the large scale. So it would be amazing to extend the online community to continue testing, to get more feedback on usability and user friendliness, and also to create more data sets, like for diverse application contexts, maybe even the little business data sets, for instance. And also it would be amazing to extend the tool itself, I mean, to add some more profound noisy data handling, or also to limit the maximum tree depth or handle overfitting, for instance. Okay, so that's all for now. Thank you for your attention, and now will be time for questions.
Thank you very much, Miriam. Are there any questions from the audience? Again, you can either unmute or ask questions in the Etherpad.
No questions? Okay.
Peter has a question. Go ahead, Peter.
Okay.
Yeah, sure. I mean, the obvious question from my side, and to make more work for you, are you considering extending this tool? Because we saw something a bit similar from Rebecca on last week, the Webinator, but I like this online approach as well, so that you have a website you can dial up and load and save. So are you considering other classifiers, for example?
For now, not yet, but we don't know, maybe in the future. But right now there is no ongoing project in that direction so far.
Because I'm asking this because for sure the nice thing about decision tree is people can follow up on it and understand quickly how the decision is taken. So the ominous question then after extending would be which classifier or which architecture to choose, especially for beginners. That's very important.
Yeah, makes sense. Thanks for the feedback.
Sure.
Okay.
There's one comment in the Etherpad saying, I like it. Sometimes I wonder if trees are easier to understand than regression approaches. Maybe you want to say something to that?
Yeah, I mean, I think that the binary split, or if you classify a problem, it's easier to grasp because it's a bit less complex than regression. But again, it depends on the background of the student, because I think that if you're from an engineering background or from a mathematical one, you kind of like are more used to using graphs than if you come maybe from a law background. I don't know. So that's what I would say. Yeah.
Okay. Thanks again, Miriam.